invite Mr. Tom Sims to moderate the next panel. Tom is the Acting Principal Deputy Director for the Department of Defense Office of Systems Engineering and Architecture. He leads the efforts to advance the engineering practice within the DoD to include systems engineering, software engineering, digital engineering, and specialty engineering areas such as reliability, manufacturing, and human systems integration. Mr. Sims also leads workforce development initiatives to include guiding the engineering and technical management, ETM, and test and evaluation workforce. In this role, he leads the effort to identify skill gaps and build the ETM and T&E training frameworks that include training materials and credentials to continually improve the professionalism of the defense workforce. Tom, over to you.
Okay, thank you everybody for coming to the Leading Innovation and Digital Transformation through Standardization. We have 3 panel members today. One of those is virtual, and I'll introduce the panel members virtually. We have Mr. Paul Lambertson. He is from the Boeing Company. Paul leads the Boeing Company's product strategy, standard strategy, and organization. Paul has held key leadership roles in Boeing, including chief engineer or system engineering for Boeing commercial airplanes. Up second in the panel is Dr. Richard Forselius. He's from Lockheed Martin Corporation. Rich has worked to develop and execute a strategy for engineering standards and practices, as well as industry association engagement. Rich was part of the RMS Sikorsky acquisition, where he served as design for environmental safety sustainability program leader. Mr. Darryl Howell, he is the Chief Operating Officer and Principal Systems Engineer at PCG Solutions. Darryl also supports the Office of the Assistant Secretary, or the Office of the Undersecretary of Defense for Research and Engineering. In the System Engineering and Architecture group, that's my group, Darryl participates in the Digital Engineering Working Group and played a significant role in supporting the development of the digital engineering strategy, and he'll give you an update. So thank you. We have three presentations. Up first is Mr. Paul Lambertson. So over to you, sir.
Great. Hey, good morning, good afternoon, everybody. So thanks for taking the time to, come and spend a little bit of your intellectual capital, as it were, to kind of understand a little bit more about what we're trying to work through today. This panel, Leading Innovation and Digital Transformation through Standardization. So I'm Paul Lambertson, happy to be here. And if we'll go to the next chart, please. I have 2 charts that I plan to share with you today. And the intent is that we'll go through and just have a good conversation on that information. And if you guys don't have the charts, just let me know and I can share it from my side.
Okay, Paul, thank you very much, because we did not get your chart. So if you could share from your side.
Oh, we had double checked that yesterday and it actually had worked. So let me do a little magic over here. All right, looks like everybody can see those charts. Let me blow them up. Yeah, of course. There we go, excellent. So what we're looking at here is, I'm gonna give you just a brief overview of what product standards are in the Boeing Company. Like, how do we do this, right? The intent of sharing that is to help then open up a set of Q&A, if you will, on how we might walk into a digital transformed state. I tell everybody, standards are the critical thread to the digital thread. And that's kind of the lasting message. So this first chart here is just a little bit of a brief introduction as to what we consider standards. For us in the Boeing Company, we have a lot of them. And I think most of your OEMs do as well. We're talking on the order of more than 100,000 of the internal ones and more than 100,000 of the external ones. So standards from AIA, SAE International, AIAA, right? So what are they? Basically, they're artifacts. They're things that we use in our product definition. Everybody likes to call them specs. Well, that's a material specification, a process specification. All these engineering documents, tech orders. I mean, most of you in this audience probably have a good understanding of what that actually is. The part models is something that really might be one of the earliest ways that we can adopt how we move more into a digital transformed space, right? Because we do most of these part models already as a model. It's in CATIA. It's already a CAD model of some sort. how do we go ahead and move into creating a standard ontology, if you will, across all of those spaces so that others can play as well and not trip up a whole bunch of different systems. So this library that we have, so we have another 500,000 plus documents that are stored in our Boeing engineering library because we covered the life cycle of our company, right? So we actually have that reach back capability. Sure, some of these things are obviously scanned in items, but the idea is that the data is there. And again, chemical profile. How do we go about understanding the chemical makeup of our aircraft, of our products, right? We have this PCPS organization that actually works for me that does that analysis. And so one of the things that we talk about from the Boeing company is by putting standards underneath one kind of system and one organization, we have the ability to really focus in on being more efficient. We have an ability to really focus in on going across all the different stakeholders and saying, hey, what do we need to be more standard? How can we be more helpful while at the same time not eliminating the monetization, if you will, that separate special space that people might be able to go off and say, oh, hey, we do this in a special way that helps us out. So you've got this competing set of priorities as to how we might really propel ourselves forward as a business, but also propel ourselves forward, as an industry. And it's that standardization piece as we talk about the broader industry and all of these areas that you're seeing on the screen that I think are really something that can be very helpful for us. So how might we go about achieving that? So I got this role 2.5 years ago, and we kind of pulled together a bunch of key leaders and thinkers and said, what is it that we think is the most important in the delivery of this product, of what is a standard? And down here, and I'm not sure if my mouse is working, but down here in the lower right corner, you see the mighty C-17. Yes, I did fly that airplane when I was in the Air Force. But it's a great picture, if you will, of just a product, but who's most important in that product? And it's that mechanic. She's the one that we care about, right? So she's the one that's actually building the product that we're going to sell. So how can we focus in on her user consumability? If a standard doesn't communicate, isn't consumable by the user of the standard, it's useless. And in fact, I would go one step further. It's not just useless, it becomes harmful, right? It now becomes something that inputs error, inputs mistakes into our products. Ooh, hey, okay, that's something we should really focus in on. So we talk about having the right information on demand at the point of need. It has to be simple, agile, and portable. So you see she's got these cool, virtual goggles on, right, to help her do the right thing. And she's got her funky computer pad that presents the information in an almost recipe type manner. So when it's, hey, I need to drill this thing into this product, here's exactly how I need to do it. And I see it in my virtual glasses. Now, of course, we don't have all of those levels of technology, right? This is our strategy. But the strategy tells you where we want to be. We want that user consumability, first pass quality, 100% all the time, right? That simplicity of use. So how do we get there? So the things that you see above this chart, so we start down here in the bottom right and we actually work our way back up. So one of the things that we've talked about are model-based standards. Now, this is an area where we really need to focus in on modernizing, transforming in a standard way. This is that ontology conversation that I hinted at just a few moments ago. When we look at how we build products, we build them with standards, not just internally from the Boeing company, but federal, industry, and military standards as well, external to the Boeing company. Well, I don't control them, right, at all. And in fact, They are made up by members from all over industry, internationally, and those members sit in committees or working groups, and they create standards that are then released by that standards development organization that we all as OEMs can then go use. But how do we communicate somebody else's proprietary information, that SDO standard, into my digital thread, into my model? And we're reaching out to a number of folks. Rich will talk next, is one of the persons who's heard me talk passionately about this, and he's equally as passionate about it. So how do we get us as an industry, as the federal government, as the military, pulling together to say, look, we get it. We need to be standard where standards are concerned. Let me thump that one more time. We need to be standard where standards are concerned. If we really are going to go to a model-based, digitally transformed world, how? How are we going to do that? Where are we going to start? I know what we're doing in the Boeing company, and I've been all over the place trying to help people understand some of that. It starts with the real basics. What's the ontology of the model? What form are we going to all fit into to then be able to communicate across all of the users? Remember, user consumability, right? And I would assert that the more users who can consume a standard, the more money that the standard producer can make, right? I mean, the more people look at your stuff and go, wow, that's an elegant solution, to quote my systems engineering days, right? I was the director of systems engineering at the Air Force Academy, and we used to teach, hey, you're looking for the elegant solution. That's the best solution out there. And that's how we move forward and make that happen, right? But that takes effort. It takes alignment. It takes a coalition. And so part of my presentation today is to kind of plant the seed that most of you have already had planted, right? You don't need me to say it. You're probably like, yeah, let's go do that. But it's to give you some insight into how we on the Boeing side are going down this path. So then as we look up, this integration symbol is integrating across the internal standards. That's this revision process piece, and I'll talk to that in just a second. Functional excellence, which are all the people that are involved in that, and the external standards that I just mentioned, federal, industry, and military. So let's talk the external piece. So one of the other folks that's on the workshop today, the conference today, is Joy Fitzpatrick. She's part of the Boeing company with me, and Joy is fantastic, right? She brings this amazing wealth of knowledge. She's the lead of my external standards management team. So she has the technical leadership to go out working with her manager and with others to pull that content together into something that's usable. Something that we don't just throw it on a drawing. We actually understand all the different places where that's used, all the different references that pulls in or that is pulled into it, right? So a standard often references other standards. Well, what does that look like? These are the networks, the connectivity networks that are essential to do this work correctly, in my view. So this middle little tile here is what I was talking about before. I believe standards are the critical thread to the digital thread. I think if anybody wants to talk about digitally transforming, you have to talk standards first. If not first, really high up to being first. And I ask passionately, I implore those of you who have a voice to be able to help become a chorus on this. I'm serious. We need to get our minds right in this space. And the sooner we do, the sooner we propel all of us forward, in my view. What's this functional excellence piece? So that's this kind of lattice that I have over here. And it's kind of a silly thing. The thing at the bottom, these are the people that directly work for me, and the people along the side are folks that I pay for that aren't part of my organization. The point of it, though, isn't the money flow. The point of it is the teaming and the demonstration that there's just a diverse amount of, of thought and people and all of this stuff that we have to weave together all the time. All the time. So with my fiery sword and brand, going ahead of me, I speak often inside of Boeing as to the understanding of the power of standards, the import of standards, and why we need to do this work together. The last piece up here is just a simple set of steps. It's really just an icon, but one of the things that we did, and I would ask, I would recommend to all of you, if you haven't actually done it, is take your standard process or processes and lay them out like a factory floor. And that's what we did. When I got the role 2.5 years ago, I read all the regulations, that we have in Boeing to do this work. And I went back to my team of experts, and I said, guys, I'm not usually dull. I can normally figure things out. I don't understand what we're doing here. Can we look at this in a different way? Can we lay it out like a factory floor? Maybe we can apply a little constraint theory, right? Maybe we can do some other kind of interesting visual methodologies, if you will, to understand our business better. But wouldn't it be great? Because then you can teach me along the way, right? I'm new. You can teach me how do we go down that path, and they did. And it's a really great chart, basically, that lays it out for us. And as we started to look into that, we really got a great understanding of our pain points, our health measures, how we might actually be able to pull that data together, again, to go through and do our internal piece, tie it to our external piece, leveraging functional excellence all across the way, with a nod towards looking at model-based standards in the future, all focused on user consumability. So that was my 17-minute monologue. Hopefully you all found it interesting. Please, are there any questions or comments?
I think we're going to wait till the end of all three presentations for questions.
Oh, okay. I apologize. I thought they were doing them in the middle. So that is it for my presentation. So I will cede the floor back to you. Thank you.
Okay. Up next, we have Dr. Richard Forselius.
While we're waiting for the slides to come up here, I just want to say thank you so much, Michael, Tasha, for inviting me, Tom, for being our moderator. It's truly a pleasure to be part of this. Sincerely appreciate it. And Paul, you're absolutely right. You and I share a bit of passion on this subject. So I hope I can elaborate a little further on some of your thoughts there. But before I begin, don't answer this if you've heard it, all right? Why did the spider have to leave home? Of course, the spider needed a new website. So a little bit of corniness to wake you up after lunch. All right, this is what I'll be covering in the next few minutes here. The mission, value, and operations of our standards and external outreach program at Lockheed Martin Corporation, which I lead in corporate engineering. The future-oriented aspect of standardization by reviewing innovative areas that are enabled by standards. And I'm also going to mention a number of the key technologies and engineering initiatives that we're involved with. I am joined here on the panel by folks that are very oriented towards software and systems engineering. Of course, that's a key component of all the work we do. It always will be. But with the advent of the digital twin and digital models, it's expanded so much beyond that. So first, we'll speak to digital engineering through standardization, and the theme, of course, for today, interoperability in the digital thread, explore standards related to the master model, and as mentioned, the digital exchange through the digital thread, model-based engineering, and systems-based verification. That may be a new topic for some, SBV. But simulation-based verification and systems-based verification basically alludes to the need or the opportunity to perform functional tests totally digitally and the associated technologies associated with that. And we'll talk to those high priority standards and all of the relationships that have to be developed. There's a human resource aspect to all of this work. And of course, the requisite tie to business needs and the voice of the customer. And to take a standards-based approach rather than a tools-based approach. So what do I mean by that? Um, a tools-based approach means you really rely on a vendor, a software vendor, a third party, if you will. And I find that many folks that I deal with, many software folks, speak to the value of particular platforms by particular vendors and what have you. But we must have the standards to make it um, vendor irrelevant, especially to enhance the supply chain. So any of our digital transformation of parts that are coming from suppliers and what have you, they're agnostic as to which design system they're using. So first, to our internal organization within corporate engineering. Our mission, support subject matter experts in targeted areas. We call these point of contact. We try to put our best and brightest technical fellows into the technical committees that are relevant to our interests here. Internally, we have functional leadership teams that we coordinate very closely with in areas like transformation, emerging technologies, and many other areas too. This is really the high level mission here to understand our business areas. Lockheed Martin has four separate internal business areas if you're not familiar with the way the company's organized. So internally, it's a challenge to coordinate the interests of our aerospace side with our missiles and fire control side, with our hovercraft business, and some of our other businesses too. These interests may not be all congruent, if you will. Therefore, we have to collaborate internally and across the company to align our standards. And those representatives that I place on the committees have to truly represent the entire corporation. Even though many of these are technologists from a particular business area, they have to take into account and coordinate with the needs of the other business areas there. And as we all know, with standards participation, the human resource element means you must influence, you must bring forward the best thoughts and ideas relative to the emerging technologies. You have to have the savvy to work with others of like minds and develop positions so that the document, the standard, or whatever you're developing represents those interests. And this isn't just design. I mean, this is the product life cycle from your suppliers through design, through your manufacturing, and through your sustainment down the road. And sometimes it's a challenge to find these SMEs. Many are more senior. I like to take more senior people. They're well knowledgeable in their field, but we have to bring forward emerging participants also. I try to do that with a mentor-mentee approach whenever I can identify someone that's interested to partner with our more senior person. Internally, we have resources. I have a dashboard that indicates all of the work that we're doing, how we're aligned, all of the technologies we're supporting. And that's also reinforced by a monthly newsletter. I speak to significant standards published under development, industry association activities, and conferences and other events to get the word out through internally. And slide 6 here. Yeah, to execute this mission, we implement a thorough strategy, align that external engagement with digital engineering and digital transformation, something we've been very focused on for a number of years here, to bring into that all the emerging technologies, to rank those priority focus areas, as well as I mentioned, the business areas and the functional leadership team needs. Uh, as I mentioned, covering the full product life cycle, prioritizing those interests, coming up with an annual plan within the budget allotted, um, and also engaging, as I mentioned, those uh, LM fellows and whoever we can externally. Now, as we all know, this is an adjunct to our engineers' day job. And a lot of this is done on their own time. Certainly, we have travel. Um, I find also that some of our more senior technical people have never engaged in industry activities. And I find the need to help assist them with the committee rules, with the expectations around attendance, our internal expectations around coordination and communication also. So there's, that, again, that human resource element to that. In terms of interfaces, our strategy requires us to interface with numerous entities, as you know, internally and externally. Our leads interface internally with corporate engineering, especially leadership and directives coming from above, if you will. Certainly from our program office, our customers, coordinating our suppliers' interests too, using as many technical resources as we have available, participating directly in the SDOs and industry associations as necessary, covering the fees if there's participation fees or membership fees, if you will, tying into many other disciplines internally, functional and business leaders, and again, engaging those subject matter experts. So our internal network looks like this. This is really a high-level view of our interfaces. It's a complex network consisting of entities and standards, operations, technology, programs, procurement, et cetera. As mentioned there, relative to standards, we identify, coordinate, and we look for the common processes that we can implement across our businesses. In operations, you've heard some discussion on additive manufacturing, the digital thread and how it feeds directly into our CAM type equipment, if you will. Anything that needs to be product specific. And I want to kind of say the word reuse. Reuse is big here. And of course, like any other aerospace company, we have many derivatives of our designs. And as much as we can reuse, the better, to be able to support foreign military sales or other derivatives. So that term reuse tends to go a little bit farther than the word standards internally. We also have to, as mentioned, be aligned. We've got to be on top of all the technology guidance. We've got to be coordinated with programs. So who are our partners in interoperability? I have 2 slides here of some of the organizations that we're directly involved with. I won't read through them, but external operability is fundamental to implementing our strategy. This, of course, list is a representative of some of the organizations and some of the committees that we're involved with, but certainly is not all comprehensive. So our focus areas. Now I'll start talking about some of the specific technologies. While partnering with these organizations as well as internal bodies, we focus our efforts as needed to target areas that are key to the future of aerospace. Within our digital transformation initiative, we focus on, as mentioned here, model-based enterprise, the importance of outreach in our industry leadership roles, uh, convincing our representatives to take on those chair type positions, if you will, and have a transparent selection of our impactful activities. What do we mean by that? That we are always assessing the value and the impact to us and aligning and coordinating as required. Our interoperability focus areas, I mean, these are a lot of the words that you're hearing these days, but these are the overarching areas that we're focused on. Digital data engineering, digital transformation, the digital exchange, and the digital thread. Of course, the digital true master model, including all aspects of the design in a true master model. Of course, that is a dream for all of us to be able to incorporate all of the design information from piece parts up to the entire airframe, if you will, in a digital model. And of course, software engineering, we do a lot of work in our software factory, and as mentioned, systems engineering. But the ultimate goal on this is to have a true digital twin of any piece parts, of any components, of any of our LRUs, our line replaceable units and systems, and even to the point of the entire aircraft or entire system. So our standards include sustainment. I always need to think about sustainment and the parts and the availability. You heard already here, we talked about microelectronics and many of the challenges there. You know, the challenges for aerospace in general to purchase parts when our needs are small compared to many other industries. Um, how to deal with megadata, mod sim, DevOps, cybersecurity and blockchain, AI, as we mentioned here, again, the software factory and software testing, which brings me back also to simulation-based verification, um, the hardware testing and materials declaration relative to the emerging chemical regulations internationally to allow us to sell a product internationally, even globally, if possible. That can be a significant constraint for us. And I know Joy Fitzpatrick's on the line here too. That's something that we work through our committee work on the elimination of many of the hazardous materials. And of course, where we can incorporate open systems in our work through OAGIS. Software and systems architecture is a key focus of us. As mentioned, the open source, also quantum computing, a little bit more down the road there, advanced communication, digital reality representation, and where we can, I work corporate agreements with the key SDOs that we have interest with. So how do we prioritize all of this? We can't look at everything at the same time. We also can't be arbitrary on what to give greater attention to. Another key thing with this work, as you all know, is you can't change year to year. And I get a lot of challenges on that. I try to maintain a program that's about 80% the same next year from this year, incorporating the latest and greatest, recognize the new working groups and committees that are being developed, et cetera. But the worst thing for my subject matter experts is for me to pull the rug out and say, well, guess what? You're not funded next year. Thanks, goodbye. You need to have some level of support over a period of time there. So we have this prioritization criteria. I get a lot of inputs on that. We have a numerical scoring methodology there. We look at the business aspect and we evaluate the standards business plan and timing on an ongoing basis. And very soon we'll be creating our year 22, our year 23 plan. Our year 22 comes to an end early. So these are key prioritized technologies. Some of these are repeated, but it gives you an idea of the focus area. And I think it's good for us all to understand what key aerospace primes and subprimes and contractors to the DoD have on their minds so that you can help us in some of these areas so that we get your interaction and we're coordinating closely with you on many of these subjects. So, what are the challenges? The links between and among the engineering community and the standards users. How to coordinate, how to communicate, mitigate the attrition. Again, that human resource element. Retain the best available SMEs as I can, expand the breadth of our representation in SDOs. And that's really why I was brought on to lead this program at Lockheed almost 4 years ago, is to really look at all of the technologies being worked in various SDOs externally and recognize that Lockheed Martin needed to place our representatives out there. I think industry could do a much better job of getting our best experts in the committees. And I'm absolutely determined to be certain that Lockheed's participating at those committees of relevance to us. So standards have to be seen as enablers. We all know that, right? So now I'll reiterate the value of standardization and look at some examples here. Um, Paul and I and others in with our work in AIA, I chaired the Standards Governance Board there for several years. We developed the future of aerospace uh, document, aerospace standards. We published that this year. The link is available if anyone is interested in that. But we gained consensus on where we should be going as aerospace relative to our standards and standardization. We become truly a global industry with worldwide suppliers and impact there. Our standards represent the largest source of our technical data for our products. Um, they're used to design, develop, and integrate throughout the life cycle and supports that global industry. And the aerospace standards system is cost inefficient and needs to resolve duplication, overlapping, discord, quality deficiencies, and other shortcomings. Standards that are aging, that are not being reaffirmed, old standards that should be eliminated, et cetera. So, and we do, as Paul mentioned, with Boeing, the hundreds of thousands of standards that we all use, plus our internal standards, and the 150 or so organizations that we need to support there. We have hundreds of experts out there. We've got to be certain that they're properly aligned with our customers' interests, with our own internal interests. Um, Aerospace companies need to come to the table and invest more in reviewing the entire landscape of standards activities to provide the guidance to the SDOs, to our friends at the DoD, et cetera, in terms of what we can do collectively to create those efficiencies. Each SDO's infrastructure is different, must be understood, as I mentioned. Aerospace hasn't done enough to rationalize the various SDOs. There's really no one entity internationally for all of aerospace. I'm not saying there should be, but we do need better alignment and agreement on what are the priorities and what is the future. Agreement on the year 2040, for example. We've got to have true interoperability, best value competition, et cetera. We've got to implement these efficiencies. We've got to involve the vendors, the suppliers, wherever we can. So we must recognize, assess, and influence the characteristics of industry discussions related to digital transformation. Internally, I have this watch list, as I mentioned, of all of the work that's ongoing. We also have to understand community regulations and the implementation of voluntary standards. We also have to abide by regulations wherever we're doing business, as you know, and where we can influence. This, in the end, as I mentioned, it not only furthers our technologies, but it increases our efficiencies. And finally, on the enabling the emerging technologies, the technologies are impacting standards. We need to get the standards developed at a faster pace. I think we're doing that. I think that the SDOs, there's a little bit of a wild west there with new technologies. We have to rationalize where the work should occur and provide that level of support. There are non-traditional entities. Consortia, for instance, non-US entities are shaping standards. We've heard a lot about China here also. I am the ISO TC20 chair, which is aircraft and space vehicles. And China always is participating very strongly, sending a number of representatives, as well as some other countries that may not be friendly to us. We need more work in our international delegations. Joy on the line here is our U.S. TAG chair there to TC20. I know she would benefit by having a much larger group participating in the TAG. Our focus has to be expanded to yield that influence in digital transformation. We've got to think of the whole product life cycle. We must partner with and influence emerging customer directives. We need to get that information very quickly from the RFP stage, the RFQ stage, into the contracts and into our designs. So standards integrate data. As we know, we're in a world of e-business right now. Integrated tools must be adopted by the OEMs, and they all must be based on standards. And we're not keeping up with changes, in my opinion, as well as quickly as we could. We're still creating documents instead of digital data. So the digital transformation of industry and company standards results in efficient machine-to-machine data transfers. So I'm a big proponent of what you heard earlier today on standards as digital data, smart standards as ISO calls it, machine-readable standards as others call it. I know the DSPO calls it documents as digital data. We're all kind of talking the same language here. We've got to integrate these accurately. We've got to have our best technologists in the committees up front. We've got to trust that the standards are accurate and published, and then we won't have the human readable content once the standard is published. It will be directly integrated into our designs. And as I mentioned earlier today, the question is not when, not if, but when. How quickly are we going to truly adopt digital standards? And these tools have to be platform independent too. It kind of goes back to my discussion on the suppliers versus standards approaches. The standards have to keep up with the technology, and that may mean very frequent revisions. To enable digital twins, we have to have customer acceptance. And that includes acceptance of the SMART standards, acceptance of simulation-based verification instead of test cell-based verification. And that is going to be very key to gaining efficiencies. I mean, I don't think we're ever going to eliminate flight tests, but many of our other ground tests and other work, we should be able to simulate rather than to actually conduct in the physical test labs. I'm here to help influence the DoD and other customers in your development of requests for proposals so that they include this standards-based approach to deliver digital renditions. And standardization across the services is needed too. We hear that because we serve really, frankly, all of the services. So the conclusion here, innovation, model-based engineering, and digital engineering must be connected cohesively, and that's connected internally with digital manufacturing, sustainment, and procurement. Our consensus must be requisite across the industry. We have to do that quickly and thoroughly, not leaving anyone out there. This influence has to shape both our industry and customer thinking. So it takes more than just a part-time subject expert doing it on their own time. We need to recognize these technologists that are working as SMEs, that this is a key component to their work. It's included in their annual reviews and what have you there. We've got to come to that industry consensus. We recognize our SMEs possess advanced technical knowledge and that they're skilled influencers, and they have to very quickly be admitted, oriented as new representatives in some of the committees. Um, so, my activity is ongoing. Please feel free to contact me at any time. You've got my email address there. Thank you. It's been a pleasure speaking with you.
Okay, thank you. Up next is Mr. Darryl.
All right, good afternoon. Okay, we can do a little better than that. Good afternoon. All right, so my name's Darryl Howell, and it's an honor and a privilege to be here. I'm here on behalf of Lieutenant Colonel Vince Ray, who is the director of the Digital Engineering Modeling and Simulation Organization, works for Mr. Tom Sims as a Systems Engineering and Architecture at OSD R&E. So again, it is an honor and a privilege. Let me give you a little bit about my background, then we'll get straight into the topic. So I am a warfighter first. I just retired from the Naval Service April the 1st after 30 years, about half and half active duty and reserves. Actually served shoulder to shoulder with Mr. Michael Hafey. So proud of your service. Thank you for all that you are doing and leading this organization. And again, it's just a privilege to see you in this role. But I'm a warfighter first, been at the tip of the spear, and I know what those mainly sailors need day to day. But I'm also an engineer as well. When I came off active duty the first time, went into my first organization working on a program, I was handed this defense acquisition life cycle, and I'm like, oh my goodness, I got to learn this thing. But you know, so I bring all of that to the table. For the last 10 years, I have been supporting OSD in a number of roles. For the last 6 years, I've been supporting digital engineering. So today I'm going to talk about the digital engineering strategy and implementation. The strategy came out about 5 years ago. Many of you have probably read it. But one of the goals that when we sat down to write the strategy, you know, our goal was to connect people, processes, data, and capabilities so that we could solve problems, solve complex problems, solve it faster, and get technology in the hands of the warfighter quicker. When I look at the DISPO mission, right? So you all's purpose, you talk about championing, champion standardization throughout the department to reduce costs and improve operational effectiveness. A lot of synergy in those two statements. So again, by this invitation, and we work very closely together, and I really thank my two partners that have come before me. We have to be in this together. The standardization community, the digital engineering community, standards are a key enabler to helping realize the vision of DE. Okay, so I think Dr. Honey briefed yesterday, so you all probably saw this slide. But again, kind of what's our role at OSD R&E? And I do need to provide a disclaimer. I'm a contractor, right? I don't speak for the government. I make recommendations. I work for the government here. And so, again, I'm just here to support. So again, our role at OSD R&E, we do champion research and technology. We are in a great power competition. You look at what happened yesterday, right? We had a presence in Taiwan, right? There's probably going to be some blowback for that. We are in a great power competition. If you talk to the cyber engineers, they will tell you we are at war today, right? So how do we maintain our technological advantage? Well, as R&E, we have to make sure that we are investing in the right things, and then harnessing that tech innovation that's happening in industry, that's happening in academia. How do we harness all of that to stay ahead of our competitors? Right. So I think you all have next slide. Okay. So a few years ago, we focused on modernization priorities. Where are those hard problems that we have to solve? And so we developed these modernization priorities. I think there are 14 of them now. And there is a principal director that's assigned to each of these modernization priorities. One of their responsibilities is developing a roadmap and kind of providing a cross-cutting recommendation for how do we get after closing the gap and making sure that we develop these critical technologies rapidly, prototype them rapidly, and then making sure that we can experiment. So again, it's about cutting down that time about getting technology to the warfighter. So if you've read the National Defense Strategy, you know it talks about kind of transforming the foundation of our force, right? So we do have to, we've got to change the way we do, but we can no longer take 8 to 12 years to get from a requirement or an idea into the hands of the warfighter, right? So our response, we've got to prioritize the speed of delivery and continuous adaptation. Many of our systems stay in place for 35, 50 years. So, how do we continue? How do we upgrade our systems continually to make sure that they're relevant? So, when we sat down to write the DE strategy 5 years ago, we were responding to this national defense strategy. And so, our objective was to guide the planning, development, and implementation of digital engineering across the department, right? There were a lot of things that were going on in pockets of the department. And so there was this groundswell among the services for us to write this document. We had to write it very carefully, right? So we had to write it in such a way that we wanted to describe what digital engineering what digital engineering is, not how to do it, right? So at that time, and it's still that way today. There's OSD doesn't have money to go provide to the services to say, hey, go help implement this vision, right? So and the services at that time, they didn't want to be told how to go suck an egg. So we wrote the strategy that talks about what digital engineering is, not necessarily how to do it. And so I would argue the impact has been viral. I have not been to a conference in the last 5 years where I still haven't seen many of our graphics that we argued painstakingly over many, many hours. Phil Zimmerman, who's retired, Dr. Tracy Gilbert, who kind of led us through developing this strategy. We spent a lot of time on this document, but I think it really has gone viral. But it talks about how are we going to conceive, build, test, field, and sustain our national defense systems? And as Mr. Griffin talked about at that time, at the speed of relevance. So we had a lot of collaborators. We didn't do this on our own. We went to groups like NCOSI, NDIA. We went to Lockheed Martin. We talked to Boeing, talked to Raytheon, a number of the companies. And what are those best practices that you all are already doing? And how do we put this together in a document that's going to mean something for folks? So again, that was 5 years ago. If Colonel Ray were here, he would say, well, that was 5 years ago, right? We are now into implementation. We really don't like talking about the strategy a whole lot because the services are already moving out. So what I want to spend today, if you haven't read the strategy, I encourage you to do it. It's up on our website. We tried to write, clear goals, but I'm going to talk about some implementation, what's been going on in the services since then, and then try to tie it to why standards are really important. So again, these are the 5 goals that are outlined in the strategy. I'll go through each of those goals today. But digital engineering, as most know, is a model-based approach that incorporates digital practices and the computing infrastructure to enable the delivery of high payoff solutions to the warfighter at the speed of relevance. So again, I'll go through each of these goals and then kind of talk about some updates. So goal number 1. Goal number 1 talks about formalizing the development, integration, and use of models to inform the enterprise decision making. So again, this is about making decisions. How do I formalize the planning for those models? How do I develop, integrate, and curate those models across the life cycle, and then use the models to support engineering activities? So again, the strategy kind of talks about what that is, Since that strategy has come out, each of the services has developed their own implementation plan. And part of that implementation plan was to instantiate digital engineering and policy and guidance. OSD is doing that infusion of DE practices into policy and guidance. The services are doing it as well. If you read the SEP 4.0, we do include planning and guidance for modeling, simulation, and digital engineering. Pretty soon, you're going to see a new DoD 5000 specifically for digital engineering that's being reviewed right now, that's going to address the use of models to make informed decisions. So again, it's about formalizing the development and use of models across the life cycle. We talked about the DEXWIG a little while ago, but each of the services are really moving out with respect to goal number 1. And goal number 2, very closely related, how do we provide this enduring authoritative source of truth, right? So to me, this is the hardest goal of all, because it requires everybody to buy in. It requires everybody to have an environment, access to that environment for the right data, for the right use at the right time. And there has to be governance of that authoritative source of truth. And then how do I use that source of truth across the life cycle? So if you were like me and you came up in a world where you would go to a program review, one of the strategies in the program review was, I want you to fill this room with documents, right? Like stack them as high as you can. And when you stack documents as high as you can, it was almost like that was a measure of how mature your program was. We can't operate like that anymore. And so goal 2 talks about, how do I provide that enduring authoritative source of truth? To me, these 2 goals, this is where standards become critical. Like if we don't have a standard way of doing this, can we perform digital engineering? Sure. Can we do it well? Maybe. Can we do it better? Absolutely, if we're doing it via a standards approach. So again, we are at OSD and the services. We are infusing a lot of that language into our policy and guidance. The services are developing digital or contract language that requires the development and delivery of models-based documents. And so, we're developing mission threads and OSD, we have mission engineering, that one of the primary deliverables out of that whole process is to provide this mission thread that's used downrange. But it's all about the data, the exchange of that data through this authoritative source of truth. So I would argue that there are a lot of folks that are working on standards in both of these areas, right? There are folks that are working on model standards. There are folks that are working on data standards. And my fear is sometimes a lot of that effort, great effort, it's happening in silos. And so, how do we bring those things together? And when we start talking about digital twins, I mean, that's the nirvana, right? So how do we make sure that that's done in a way that's standard, so that so that those systems can perform as they were designed? So digital engineering isn't some nirvana that's going to come solve all your problems. If you're a bad systems engineer, right, and you start applying digital engineering principles, you will get exposed, right? So Phil said that Phil Zimmerman used to say that a whole lot better than I just did. But it's this isn't going to solve all your problems, but standards, again, that's the enabler that can really help us realize that vision. Okay, goal 3. This talks about incorporating technological innovation to improve the engineering practice. So this is where we get into the digital twins, right? So we are focused on leveraging high performance computing, cloud networks, and open standards. And so how do we harness all of the power, again, that's going on in industry and in the services? How do we bring all of that technological innovation and stay up to date, right? And don't get locked down into a particular tool or a particular vendor. And now I can no longer um, harness, again, that tech innovation. And then how do I use this tech innovation to improve the digital engineering practice? So there's lots of examples that are going on in the services. You can read all about the Air Force's digital campaign. Navy's got a digital transformation effort that's enterprise-wide. Army has their own digital transformation strategy, and there are some cutting-edge tools out there today that are popping up all the time. And so I think, some would argue, well, Darryl, digital engineering isn't new. We've been doing this for a while. I would submit we now have the computational power and the tools to do it right. Right? We just got to figure out which ones and not get locked in. And one of the things that the DEXWIG is attempting to do, again, how do we exchange those digital artifacts so that it's about communication and about managing that data across the source of truth. All right, so goal number 4, one that's near and dear to my heart because I think I spend the most time on that one, establishing a supporting infrastructure and environment to perform the activities. Where are you going to do these digital engineering activities? Right? We almost didn't add this goal to the strategy because doesn't this kind of make sense? Don't you need an environment? But you'd be surprised. There are organizations. I love the Army's new strategy. Like the PEO's got the dot on their forehead that you are required as the PEO to make sure those programs that are under you provide that ecosystem. Right? Provide the engineers the access to collaborative tools. Some of these tools, as you know, are very expensive. How do we share those tools across the enterprise and make sure that those tools operate like they're supposed to? Guess what? They operate different in the cloud than they do on your desktop. And what's the latency required? How do you get after security and at different different levels? So again, there's lots of efforts that are going on with respect to this goal, and so again, having a standard approach to being able to exchange data across these ecosystems and the enterprise is important. Many of you have probably read the 5 DoD data decrees, right? That mandate that we share data and information. Well, if we don't do that in a standard way, are we any better? Or not? Okay, so let's see. Okay, so goal number 5, this one almost didn't make it either, right? So this is about transforming the culture and the workforce to adopt and support digital engineering across the life cycle. So making sure that we train our workforce, we change our mindset, right? I grew up in a world where data was we didn't like sharing data, we didn't like sharing information, and because we didn't like being transparent. But we've really got to change our mindset, and we got to change our mindset with respect to standards as well, right? So it's no longer about that document, it's a view. So how does my standard change when I'm trying to produce a view or a digital artifact, or the model is actually going to produce that which I'm trying to conform to? So again, it's a different mindset, and we've got to train our workforce to do that. And there's lots of efforts that are helping move that out. We do have a digital engineering body of knowledge. And if you need some more information on how to access that body of knowledge, please see me afterwards. There's a link on our webpage to that as well. Air Force has got a wonderful digital guide. Navy's got a MBSC guidebook. The Army actually has a body of knowledge as well for digital engineering. So again, I think there's a lot of momentum, but there should probably be more momentum in terms of making sure that we do this in a standard way. So again, I'm not poking anybody. I'm just saying we're in this together, right? We're in this together. So I think, and I was going really fast, so I don't know if I went too fast, but I'm very passionate about digital engineering. It is about getting technology in the hands of the warfighter. and making sure that we win this great power competition. And we've got to do it with transformative methods, processes, and tools. That's all I have. Thank you.
Okay, thank you. 3 great presentations. So now we'll open it up for questions. I think we have about 20 minutes. So both virtual questions and in the room here questions. So, okay.
I gotta hit Darryl while he's still hot coming off the mic. Like goal number 4, you killed me on that one, right? For like support the digital infrastructure. It's like point blank, goddamn Google ruined it for everybody, right? Because if you want to get a bill payer to pay for like the digital infrastructure, the first thing that comes out is like, well, how come I can Google stuff for free? Why does it cost me money for that? That's so hard. Like, how do you put bite behind goal number 4?
So I'll answer my opinion if Mr. Sims wants to come in and come behind me. So I think from what I've been tracking, competition is driving that cost down. So so having more options, but making sure that we are interoperable and can exchange data, that will continue to drive that down. But yeah, it's a big issue. So the way I see services attacking this today is they're partnering and trying to share that cost burden across the enterprise. Did that answer your question?
I mean, yeah, it helps, but it seems like, when it's always that's always the easiest thing to kick off the table for someone not to want to. It's the easiest one to shove aside for. I'm not going to pay for that, and it's just. But it's you can't do anything if you don't have the infrastructure.
So there are efforts under TRMC, Gemetic. I don't know if you're familiar with Gemetic, both unclassified and classified, that they're trying to expand that to help the digital engineering process and acquisition programs. So there's a big investment in Gemetic right now, continues to be over the years. So hopefully we're giving programs the opportunity to use that, not necessarily saying they have to use that, right? So, but we're always open to other alternatives.
So I guess this is for the whole panel, but I'm gonna start off directing it to Darryl and Tom. Darryl, for each one of the goals that you put up there, you had an Army response, a Navy response, an Air Force response, and then you put up a digital guide and a body of knowledge and an MBSE. Do we have the services actually coordinated on an approach, or are we fostering at least 3 and maybe 4 or 5 different approaches that you say need to be able to talk to each other? And is that driving folks like Rich Forselius and Paul Lambertson to have to respond not to a DoD approach, but to an Army approach or a Navy approach or an Air Force approach?
Yeah. So great question. I think there's a balance, right? So what we've tried to do at OSD is kind of be that glue and that belly button for all of the services through the digital engineering working group and provide that forum for collaboration. We do get to review a lot of these documents as they come through. And I'll tell you that having reviewed all of them, there's a lot of synergy between them. Could we be doing a better job at making sure that the Lockheed Martins of the world don't have to, because you're supporting all 4, and now there's Space Force. MDA's got their own. I only put up some of them. Space Force has a strategy. MDA has a strategy. So we are going to take a look at that as we go into this next phase and demand signal from the services. Do we need to go to a deeper level to make sure that coordination is happening? But all of those strategies point to the OSD strategy. So I think there is some synergy there. And Tom, I don't know if you want to provide a different.
I think you hit it on the head when you said we need to go towards standards-based and not tools-based, right? If you get standards-based, you can help the interoperability between the services and that's where in my opinion, we need to go.
Yeah, and just let me add, know your audience. At least that's where I come from right here. You might have quickly seen me flash by the need for standardization across the services. It is key for us that more be done in that area. I have an SME whose sole focus almost is to assist with that, to influence where he can with that. But we do supply all of the services plus the Space Force, and so much more could be done there. Thanks for bringing the question.
Hey, and this isn't so much a question as a comment, kind of contextual add-on. Great comment. We've wondered that all the time, kind of on the ground side. I'm with POGCS up in Detroit, the ground combat fleet. So as you ask the question about digital engineering and the three different approaches, and then you put that in the context of JADC2 and future interoperability, how are we, and again, not a question, just kind of adding on to the comment, how are we ensuring in a digital twinning, in digital engineering environment, all our focus is on that JADC2 capability that we talk about in conferences all the time, and then step back and think, man, that is a big ask. How are we getting to that? So great comment, and I think it just kind of dovetails into the larger problem we're trying to tackle.
No, I totally agree, right? And so there are the architecture products that are being developed that are part of that effort. All of the services and the joint staff and OSD are playing a part in making sure that those are reviewed and developed consistently, so that we don't end up with an inoperable system 5 years down the road. Over.
Yep, agree. Question. So leveraging the well-worn phrase, all models are wrong, some are useful. Question in 3 parts. First part on the use of models and all the standards that described 100,000 plus models instead of Boeing alone, I think was the quote. One part of the question is, as we start to increase the rate of change of individual systems and the derivatives of those systems, the use of those standards for production quality of the single integrated system has an impact to the OEM and their suppliers. How do you intend to share them? The second part of that question is, what happens when that system now requires a supplier who was not in the OEM's chosen supply chain? How do I share that? Not just the standard, but the system level quality and system behaviors that I expect as I use that standard with somebody who is not necessarily in that total system integration side. And then the penultimate question to the defense side is that behavior is really driven by the Department of Defense having freedom of action on the supplier side. So as both the industry side consider the ramifications of part A and B of that question, the part C of that question is, what do we need to do on the defense side to help enforce that behavior so that we can really get to supplier freedom for individual components and still achieve that part A system level integration? Are we doing enough here to integrate these combination of wrong models that were interpreted by a huge pool of suppliers that weren't part of the OEM's original design? So question in 3 parts, how do we integrate these models is the ultimate theme. Thanks.
So, Rich, if you don't mind, I'll just jump in real quick on the industry side. Can everybody hear me?
Yes.
Okay, cool. So, yeah, great set of questions. And there's a balance that has to be looked at. So the balance is between what's being developed that is part of the OEM's business structure, right? I mean, the OEM is there to build a product that serves several purposes, one of which is, trying to sell something, right? That's what the business is primarily there for. So there's this thing about proprietary information in contracting. So a lot of what you're talking about there is how the teaming comes together to do the actual contracting. So what is the sharing mechanism? Well, we have sharing mechanisms today. I mean, we share standards, and the 100,000 plus comment was on standards themselves, not necessarily models. I propose that the standards actually be broken down, if you will, into what we call data bits, or something that is really the smallest amount of actual data that you need to model, and then you model that. And then those sets of models that come together, almost like UML, create the standard. Now you look at a standards landscape that links in to these various models that then create the information that you need to share. What does that do for you? Well, it allows a number of opportunities. Some of these models may be for open consumption. Anybody can use them. Okay, great. If anybody can use them, then anybody can use them. There are no restrictions. Go get it. The comment that I made during my talk about ontology is, but in order to do any sharing, we all have to be in the same kind of data analysis, sorry, wrong word, the data set to be able to be consumed. So if Boeing makes something and we make this model in a way that nobody else in the supply base can consume, well, then who are we really serving, right? But it's the same way for a military standard or a government standard or any of the other industry standards developed by SEOs. Or let's say, Lockheed Martin has something that we Boeing want to use. How do we do that? Well, the how is contractually, but the pieces underneath are, is there a system that's set up that allows that sharing to take place? That, to me, is the greater question. And that's what I was imploring everybody on earlier in my comments, is to make sure that we actually have a standard way of doing that communication. So for me, that's what covers the how we get the information out. The second question you asked was about, well, what about if you're now having to work with somebody that wasn't in your original supply chain? I'm not necessarily sure how that works, because, again, for an OEM, all of those arrangements are made contractually. So a subcontractor can contract out to whoever he wants, but then that subcontractor that's pulled in an even lower level contract, if you will, that's now all part of the whole business. So I wasn't really tracking with the second question, because, again, how our methods are, it's all through contracting. So, Rich, let me throw the first two questions over to you, and then we'll sit back for the third one.
From my perspective, the issue isn't as much engineering as it is legal. And we're so hypersensitive these days with proprietary information. I've had to affect a number of NDIAs, PIAs, et cetera, and ditto with our supply folks too. I want to say that engineering is a bit agnostic in terms of where the part is procured, as long as the form, fit, function works,
Right.
However, we become comfortable with particular suppliers, and we share only what's necessary with them so that they can supply a viable part or piece of software to us. So it's kind of a multidimensional thing. And another thing too is the time element is a concern too. It takes a while to affect some of these agreements, to even put out an RFP or an RFQ to a new supplier, et cetera. And we may be under the gun. We may have an AOG type issue or what have you. And therefore, we become complacent and like to do business with familiar suppliers that already we have confidence in. But yeah, I mean, this can all be worked contractually. There's no question there. We need to do more teaming. We need more alternate sources of supply. We all know some of the challenges we're having with microelectronics and what have you there. And honestly, in some ways, there's not always an opportunity for a second source.
Okay, thank you. Any more questions? Anybody on the virtual? The chat. Okay. Okay, Michael.
Just to add on to the Lieutenant Colonel and Greg's comments earlier, and maybe focus in on ontologies. So I guess kind of two aspects to the question: one to Darryl or Tom, and one to Paul. One is there a group? Maybe it's the DEXWIG. Or is there anyone already looking at developing an ontology to support digital engineering within the DoD? And then to Paul, where do we start? We've got briefings next on architecture. We've heard about architecture development efforts. Is that where should it be in a standard, right? Do we focus at first at the system level, or do we start at the top and then work our way down?
Okay, so to answer your first question, there are some groups that are working on ontologies. That the DEXWIG is looking at again about when you're exchanging those digital artifacts, the ontology and description of how that's done, that's being looked at. But I mean, I'm telling you something everybody in this room already knows, that those are really hard to do, right? That's where the sausage, it's really, and it's like, I remember first time I was working on a DID, I'm like, why is this thing taking so long? But it's really hard to do. So is somebody looking that across the spectrum? Not that I know of, but I'll take that question back to my colleague Frank Salvatore, who's the kind of our lead on that kind of thing, and ask him.
Yeah, and Michael, for the second part of what you talked about, I think we need to just have more conversation on what is currently being done in the space. For me, I maybe look at it a little overly simplistically, but I look at it from a requirements and a functions standpoint, right? Obviously, I go back to my systems engineering roots. I think we have to have an ontology that is consistent across and is adaptable, right? You can actually add to it, but that becomes the ontological source of truth, if you will, right? It's that factor, that set of attributes that all standards would require. Now, that doesn't mean, I kind of said that a little bit off. Let me tune that a little bit. The set of attributes are the same. The standards don't all have to have every attribute full, but it still needs to be in that same space. And for the attributes that aren't full, it's just a null field, because that's what enables that universal consumability. Because then you get the data that you actually need, and the data that you don't need, there's something there that says, hey, I don't need this. And so the system doesn't hiccup because it was expecting 11 attributes and it only got 9, right? It's that kind of model sharing. And there's been a lot of work on model sharing as well. I think a good method forward, a good way to look at this would be to reach out to the organizations that are doing work in this space, starting with the Department of Defense. What have we learned so far? And maybe let that kind of start, if you will, as a primer, and then we can build from there. That's how I would go about it, go from the known to the unknown.
Yeah, thank you, Paul. That definitely answered my. I think my mic battery might be dying, because ideally we would be able to model the whole world, but we're resource constrained. So starting with what we have and building from there, I think is the right answer. It's just difficult. How do you eat an elephant one bite at a time? Well, we have multiple people eating different parts of the elephant. How do we bring them all together?
I think we had one more question in the back, and then I think.
So this question kind of relates to how we get after some of the things. So working in the geospatial community, where we have a plethora of standards of everything from web services to how you portray things and things like that. Use it or eat it. Okay, there we go. Sorry. So looking at how we get after these sorts of things, there's a critical element that we find is kind of missing, and that's the tradecraft to do this kind of digital engineering work. Many of us, as we're doing standards, are doing highly technical, detailed things with databases and websites and all sorts of things, but getting after how you can deploy those things or make those things more consumable and more useful, where you're getting the standard closer to the developer. You're not developing for them, but you're getting that information closer to them so that they can test their system or so that they can analyze what they're doing. So do you see any place for um, helping people understand what it takes to do these tasks? What kind of tradecraft or what are the critical elements to putting together a standard team to do this or being able to execute the task? Sometimes it comes down to just having a model, but who's going to do that model and who's going to help the standards organization get there and then deploy it in a way that it's useful to the community. So I don't know if that's a standard or how the community gets after that, but I think that's a need.
I think it is too, and I think there's a workforce development aspect to it where you need to train the people in the program offices that do that will be in charge of the modeling and modeling languages to help that facilitate that problem. But I think it's both.
If I may interrupt for just a moment, and I apologize, but those of us in the virtual world, I think there's a limit to the distance to your microphone, so I'm missing a lot of what's being discussed. I apologize for that.
So, Paul, I'll answer here. I'll say we can't be stovepiped anymore. I mean, I go back to the days of integrated product development, IPD, and we need to look at this holistically. We need to have truly look at this as a system. We need to engage all of those. We're too focused on each of our own technologies, each of our own areas. So, yeah, there is a craft to this that we, frankly, could do more relative to training on these subjects too. Many of these that I brought forward here, and a lot of these definitions are emerging. I'm finding some of the changes. I saw a definition of SMART standards today by George Gula using the acronym that was a little different than I had been using personally. But through all of this, my answer is look at it holistically, manage the entire project as a system, and engage all of those subject matter experts. But a significant amount of training, human resource training, is going to be needed down the road.